Dear students, as part of this paper on the data sources and population projections, the module covers the issues related to the various mathematical methods of projections and the population projection for India before independence as brought out by Kingsley Davis. The major outline of this module is mainly to cover the three methods of population projections, that is mathematical method, growth component method and economic method. Let us discuss to begin with mathematical method. As we all know that population projections are very important for various advantages in terms of its planning for the country and also for implementation of various programs and schemes, especially in the areas of socio-economic issues. One of the important challenges that the demographers experience is about the reliable and appropriate methods of choosing population projections. So, in this regard, to begin with, let us discuss about mathematical method. The mathematical method is the easiest one to be used for population projections. The resistance or the sum of the obstacles opposed to the unlimited growth of population as it increases in proportion to the square of the velocity with which the population tends to increase. It means that the growth of population declines in proportion to the increase in the density of population. Whereas in 1838 developed the S-shaped logistic curve, recently Pearl and Reed experimenting on fruit flies derived the logistic curve based on their conclusion that to begin with population grows at a slower rate and then exponentially it increases at a faster rate. After a certain stage it again grows at a slower rate and subsequently at a faster rate until it becomes stationary. The S-shaped logistic curve is useful for making population projections, but because of its complicated mathematical formula, it is not used adequately by the demographers. However, demographers use simple arithmetic and geometric formula and graphs for population projections. Let us discuss about the arithmetic method. In the arithmetic projection method, it is assumed that the annual change, the change can be either increase or decrease in population, remains the same throughout the projection period, and the crude birth and death rates are also taken into consideration. The formula for such linear interpolation is P small p is equal to P of t plus where P of p is the population projection in the future, P1 represents present population as per the recent census, P2 is the size of population in the previous census, N refers to number of years between the projection year and the previous census, and capital N is the total number of years between the recent and previous census. Based on this, the projections can be carried out. The next is about geometric method. In the geometric method of projection, the formula is P of small p is equal to P1 of 1 plus r of n, where P of p is equal to projected population, P1 refers to population as per the recent census, R refers to annual rate of increase or decrease of population, and n is the number of years. This formula is the basis of Malthus population projections. It can be easily calculated like a geometrical progression of the compound interest. However, there are certain limitations of the mathematical method, that is, the mathematical method of population projection has been, though widely used, it has its own limitations. Number 1, it is neither an adequate nor a complete method of population projections to give information regarding different age groups. Number 2, the projection is done on the axiomatic assumption that the demographic projection of the future is based on the growth rate of the past and that the prevailing situation will remain in the future too. It is thus not a real index of either the future or past trends of population. 3. This method fails to make projections about birth rate, death rate and migration because it assumes them as constant. 4. It ignores the past and future socio-economic changes that affects population growth significantly. In fact, socio-economic changes can prove that the projected information be wrong. And 5. It is possible that the formula for the logistic curve may not give an S-shaped curve due to the time series involved in it. The other major method of population projection, commonly known as growth component method. This method is more practical than the mathematical method of population projections. The growth component method, also known as the cohort component method, makes separate projections for birth rate, death rate and migration rates by different age and sex groups. In making projections for the birth rate by age sex groups, the effects of fertility rate among females, marriage and remarriage rates, sterilization rate, socio-economic factors of education, of divorce, of net reproduction rate, etc., and their influence on the birth rate also are taken into account. Similarly, in making projections for the death rate, the infant mortality rate, expectation of life at birth, the ratio of the elderly population in the total population, maternal deaths, etc., are estimated on the basis of the past census figures. At the same time, the effects of medical and public health services on the death rate are also taken into consideration. For making projections on migration, the past trends of immigration and immigration and changes in the rules of migration by other countries vis-a-vis the home country are used. Thus, by calculating separately the effects of birth rate, death rate and migration by age and sex groups in each case, the projected total population is estimated by their summation. The correctness of growth component depends upon the assumptions made about birth rate, death rate and migration rate. But there is every possibility that the assumptions may not be true and the projections may turn out to be incorrect. Now, the last method under this is the economic method. In the mathematical method and growth component method of population projections, demographic estimates for future are given on the basis of population growth rate, birth rate, death rate and migration rate. But the factors really affecting them are not kept in mind, due to which the projected statistical information remains changeable. Thus, in the effective economic method of population projections, how and to what extent the birth, death and migration rates are affected by economic factors are considered. Economic development is an important for knowing the effects of component of population, that is migrations. Due to regional economic development, people migrate from the backward areas to developed areas in search of jobs. In addition, the rural, urban, age and sex-wise number of projected laborers are to be estimated. Such changes, their effects on urbanization and the consequent growth of towns, cities and urban centers and birth rate, death rate and growth rate of population in them are to be projected. This method is more useful for region-wise projections rather than for the entire country. Let us discuss in detail about the cohort component population projection method. The cohort component techniques uses the component of demographic change to project population growth. The technique projects the population by various age groups in addition to the other demographic attributes such as sex and ethnicity. This projection method is based on the components of demographic change, which mainly includes births, deaths and migration. Let us discuss the equations. Component summary equation is expressed as P of t plus n is equal to the survived population plus births plus net migrants. To project the total population size and the number of males and females by 5-year age groups, we need to find the number of people who survive or are expected to be alive in the future, and then we need to add the survived population number, the number of births that taken place and the number of the net migrants. There are several approaches for using the cohort component technique. The approach described here is easy to use and requires a minimum demographic information. Eiserman 1993 offers planners an alternative way to employ this tool. Eiserman's alternative method uses a different approach to inputs of fertility, mortality and migration data. Assumptions are, when the cohort component method is used as a projection tool, it assumes the components of demographic change in the areas of mortality, fertility and migration will remain constant throughout the projection period. As a forecasting tool, planners can alter the vital statistics and migration estimates to reflect their view of the future. For the purpose of this section, the tool is presented as a projection method. There are major suggestions that are provided. When making a 10-year projections, it is best to perform two separate projections, that is, a projection for the first 5 years and then a projection for the next 5 years. The result of the first projection is used to perform the second round of the projections. In some cases, planners alter demographic rates to reflect their vision of the future for a locale. For example, they may observe declines in fertility levels and alter age-specific fertility rates by using some of the extrapolation tools or ratio methods as presented here. When to use this method of population projections? Use the cohort component method when population projections by age and sex are needed for 5 years, 10 years or longer periods of time. This projection tool allows planners to examine the future needs of different segments of the population, including the needs of children, women in the reproductive years, persons in the labor force and the elderly. It also allows planners to project the total size of the population. The results can be used in all aspects of local and regional development plans. What are the steps for using the cohort component method? Step 1. Collecting the necessary and required information. The cohort component method requires information from both the most recent and the prior census of the locale. Collect information on the number of births during the past 10 years. Ideally, information on births should be compiled by the age of mother so that age-specific fertility rates can be calculated. These rates are used to project the number of births that occur during the projection period. Use the general fertility rate when births by age of mother are not available. A life table or calculated survival rates are also needed. Step 2. Aging a population into the future. The cohort component method takes each age group of the population and ages it over time using survival rates. For a quick review of survival rates, please see a more detailed explanation by referring to Shrok and Siegel or Dr. Suchindan's course, the multiple decrement life tables. 1. obtain census information distributed by sex and age, which is usually 5-year age groups. Number 2, multiply the base census population of a given age group by survival rates so as to obtain the population still alive 5 years later. Number 3, what is the number of women aged 25 to 29 years who will be alive in 5 years? Number 4, women aged 25 to 29 alive in 5 years, that is population of aged 20 to 24 into survival rates. The steps 3 is adding births. Next, calculate the number of births taking place during the projection interval. Age specific fertility rates are used to estimate the number of births that taken place. The rates are multiplied by the number of women in their reproductive years. The results are given an annual number of expected births. They are then multiplied by the projection period, usually 5 years, to obtain the total number of births that taken place in the future. An age specific fertility rate indicates the probability that a woman in her reproductive years will give birth in a given year. Use the sex ratio equation as shown in equation 8.2 to find the number of male and female. Equation sex ratio, finding proportion of male births is equal to sex ratio of males ages 0 to 4 divided by sex ratio of females ages 0 to 4 plus 100. Finding proportion of female births is equal to 1 minus proportion of male births. Once the number of male and female births has been determined, the results are multiplied by a survival rate so as to determine how many babies survive into the future, as shown in the equation. Equation surviving population, that is male births that survive, is equal to male births into survival rate. Adding net migrants. Next, add the number of net migrants. This can be a positive or negative number. Obtaining the number of net migrants is a two-stage process. First, calculate net migration rates, then multiply these rates by the survived population so as to obtain the number of net migrants. These are the major 3 methods that, as we discussed, which are very important in the area of population projections. Now, let us discuss in detail the population projections for a specific country like India before independence, as brought out by Kingsley Davis. According to the size and complexity of its composition, a society is classified into small or large and homogeneous or heterogeneous. Indian society is a large and heterogeneous society. In terms of population, it is second only to China, though India's geographical landscape is only 2.54% of the world's surface area. For understanding any society, the first thing to know is the size of its membership and its distribution in terms of sex, age, place of residence, and other socially significant characteristics such as marital status, education, occupation, religious affiliation, etc. For understanding in these issues, like any social group, a society is composed of people. Its membership is recruited either through sexual reproduction within it or through in-migration of individuals or groups from other societies. Similarly, it loses its members when they die out or migrate to other places, that is out-migration. Thus, 4 factors determine the growth of a population of a given society, that is births, deaths, immigration and immigration. The actual growth of a given society between 2 points of time is represented by the following formula, that is population growth is equal to births minus deaths plus immigration minus immigration. Let us discuss with some of the facts. The latest census, which was completed on 1st March 2001 and subsequently on 2011, put the population data in terms of its size and how India is having a population when we compare with China, we are scored the second in the rank in the entire world. Next comes the United States, and then our two neighbors, that is Pakistan and Bangladesh, have their respective population, and in the global population, the India's population accounts nearly for 1/6 of the population, which comprises of 16.6% of the total population. It is important to know that systematic counting of the population in India started during the British regime. The period of modern comprehensive census began as early as in 1881. There is no dependable data, however, about the earlier periods. Efforts have been made by some demographers to estimate the size of population in earlier periods. These were based on accounts given by the foreign scholars visiting the country and the literary works of those times. Some have also tried to guess the population by accounts in the size of the army of different kingdoms, taking a clue from the European countries where the ratio of army personnel was 1:60, but this measure has been found to be very defective. In any case, we must note that all figures of the pre-census period are indirectly derived and therefore only approximations. One estimate suggests that the population of India around 300 BC was between 100 and 140 millions. The estimates made by other scholars have put the population at around 125 million in 1600 AD as brought out by Kingsley Davis, and 207 million in 1800 AD as mentioned by Mahalanobis and Bhattacharya. It is interesting that both Kingsley Davis and Mahalanobis have made almost identical estimates about India's population in 1871, which were estimated as 255 and 256 million respectively by these authors. Mahalanobis and Bhattacharya suggest that between 1801 to 1871, the Indian population grew at the rate of 0.34% per year. This increase is attributed to the peaceful conditions created during the British rule, when internecine wars, infighting and banditry were greatly reduced. The slowdown in population growth between 1811 to 21 and 1831 to 41 was due to the higher mortality rates caused by the famines and epidemics that occurred during those decades. The population of India at the time of the first census taken in the year 1881 was as low as 253 million. However, in 1901, the population rose to 294 million. 1941 census, which has taken before the partition of India of 1947, put the population figure at 389 million. Taking out the areas that went to the newly created state of Pakistan, the revised total of what was left for India was 318 million in 1941. Partition means a loss of nearly 70 million people. This in terms of 1941 census figures for those areas that went to Pakistan. But it should be remembered that there was a huge influx of refugees from Pakistan who took shelter in India, and similarly there was an exodus of Muslims from other parts of India to Pakistan. Thus, the actual size of India in 1947 will have to take note of both processes of migration, that is immigration and emigration. In this way, the data from 1941, how over a period of time it has moved, and in the subsequent year census has clearly shown the growth in the population size as depicted in the table 1 of population of India between 1901 to 2011. While commenting on the growth pattern of Indian population, the census suggests that India's population growth during 20th century can be classified into 4 distinct phases, that is stagnant population, which refers to 1901 to 1921, steady growth 1921 to 1951, rapid high growth 1951 to 1981, high growth with definite signs of slowing down has started from 1981, and this very clearly shown the decadal growth of population over a period of time for the country of India. The census of India clearly shows that the story of population growth is fairly in tune with the classical theory of demographic transition. According to this theory, the population of any given country passes through 3 distinct phases as shown below. that is one pre-transitional phase. In this phase, a society which has high almost matching rates of births and deaths, this makes the population stationary since the number of deaths replaced by the number of newborn. The rates indicate the number of persons per thousand of the population. The second stage is the transitional phase. In this phase, death rate begins to decline while birth rate continues to be high compared to the death rate, and this causes the rapid growth of population. It is also called the period of population explosion. The third last stage is the post-transitional phase. In this phase, both birth rates and death rates attain a state of near balance at low levels. This makes the population growth very slow or zero. In order to appraise this point, we should examine the statistics of birth and death rates over a period of time as depicted in this table. The table clearly shows high death rates prior to 1921. These were due to frequent famines and epidemics such as plague, cholera and influenza. The deaths caused due to influenza epidemic are estimated as high as between 8 and 15 millions. India has reduced in 5 decades, beginning from 1950, its crude birth rate, say for instance crude birth rate from 40.8 as reported in 1951 to as low as 26.4 in 1998, and it has halved its infant mortality rate, which was as high as 146 per thousand live births in 1951 to 72 per thousand live births in 1998, and quadrupled its couple protection rate from 10.4% in 1971 to as high as 44% in 1999. It reduced its crude death rate from 25 in 1951 to only 9 in 1998, added 25 years to life expectancy, that is from 37 years to 62 years, achieved nearly universal awareness of the need for and methods of family planning, and reduced its total fertility rate, which was as high as 6 in 1951 to low level of 3.3 in 1997, and the birth and death rates per thousand population during this reference period for a country as a whole are depicted in the table. So, the population figures very clearly indicate the trend that emerges in the vital rates like births and deaths and the migration flows, and that the country is passing through various stages in the demographic transition, and given the complexity of various factors, it is very important to understand these factors, and also the heterogeneity of and the diversity of the population living in various regions of the country. It clearly reveals that huge variations in the demographic data is expected, which is clearly depicted in various census operations. So, that we need to know that given this diversity, the performance of fertility is widely seen, and the family planning performance is also one of the major indicators to depict the changes in these vital rates.